traditional, all the hook process in the Linux kernel network stack. So you can directly operate on certain registers that the BPF filter could identify. So eBPF brings actually the user space programmability to BPF. So we are experimenting with Manspor and eBPF support with the goal of gaining insight into how the model is actually executed, because at the moment, all the profiling tools you could find for AI are much more high level, like for I/O, CPU usage, memory usage. But with the help of eBPF tools, you can actually know, like, in which hidden layer that calls certain kernel functions that brings down your performance. This is another very nascent area that we are experimenting with. Next slide, please. The last one is Kubeflow, which I think most of people are familiar with Kubeflow. Next slide. Yeah. So if you are using Kubernetes to manage your infrastructure, then Kubeflow is the workflow management, basically default tool for your AI clusters. So for Manspor, we developed the Manspor operator, the Kubernetes operator. So you can easily use Kubeflow to deploy your Manspor, either your training cluster or your training cluster. We have been also working on the serving side. So hopefully by the end of June, we can also provide KF serving capabilities for Manspor. And for the training, we also utilize Volcano, which is a open source project also from Huawei, to provide the batch job scheduling capability for Kubernetes. I won't delve into detail on that. Next slide, please. Okay, so you are more than welcome to check out the code, either on Git or GitHub. The easiest way to experiment with Manspor is to try with the Docker. We provide CPU and GPU Dockers, and we have a Slack channel and also a mailing list, which you are free to join and start discussions. Next slide. Okay, there we are. We are actually looking at how to integrate Manspor into the Unimatrix landscape vision, and also things like lateral support in Manspor. I think it will be very interesting. Yeah, thank you very much. Any questions? Any questions?
No questions.
Okay, then thank you for your time.
Okay. Thank you for the presentation. It's very interesting. Another model format. Could do another backend to Laravel to support it. Next on the agenda is capability API update from Dora.
Yeah. Share it right now. Okay. Can you see my screen now? Hello.
Yeah.
Yeah, can you see my presentation?
Yeah, I can see it.
Okay. We'll get started. So one scope of the Unimatrix is specifying APIs for services that the host OS provides to apps. So maybe for different services, we will provide different kind of APIs. For the common services, like get service capabilities or like get host informations. We maybe provide RESTful APIs or gRPC APIs. And for high performance requirements, as Axis presented, maybe we will provide OpenCV APIs. And for events or metadata streams, we maybe use MQTT. And also the format we suggest to use only specified formats. And this presentation focuses on the common services. So I implemented the two kinds of APIs. First approach is to specify RESTful APIs, and the second is to specify gRPC APIs. So I will introduce them. First, let's introduce the concept of gRPC. So as we all know, gRPC is an open source, high performance remote RPC framework that can run anywhere. And gRPC enables client and server applications to communicate transparently and simplifies the building of connection systems. And it is layered over HTTP2. And also by default, gRPC uses protobuffers as the interface definition language for describing both the service interfaces and the structure of payload messages. And it is also possible to use other alternatives if desired. And the license of the gRPC is Apache. Now I will introduce my prototype implementation, and I download the gRPC open source code from the GitHub, and the version is Axis, and I specified 3 RPC APIs: get host information, get service capabilities, and PTZ absolute move. And RESTful concept, REST is a set of constraints and principles, an application or design that matches these constraints and principles are RESTful. And here I will introduce 3 main principles. The first principle is each UI represents one kind of resource. The second is transfer representation of this resource between client and server. And then client operates the resource by using 4 kinds of HTTP operations. And I use the libcurl library to implement the HTTP client, and use CJSON to do the construction and passing of the JSON payload. And this are the license of these two. So this is the example of the host information definition by using JSON format. And here is the performance comparison. I tested 5 times, and as you can see, the second column is by using gRPC to do the connection. The first connection, it uses 24 milliseconds, and after the connection is built, the second and the third command just use almost 1 millisecond, and the fourth column is a RESTful persistent connection, and the sixth column is a RESTful connection. So maybe next, let's see some image to get the comparison more directly. So as we can see in these three images, the performance of gRPC and RESTful persistent is similar. Next, I will introduce the size of the dependencies. So the mean two dependencies of gRPC, we can see the static library size and the shared library size. And the libcurl, I just compiled it to support HTTP. Yeah, that's the size of these libraries. And from our side, we suggest specifying RESTful APIs in Unimatrix. Since almost all of the embedded devices support HTTP servers, so just need to add the handle of new URL. And RESTful APIs has been widely used in the opening of cloud services nowadays. So that's the update from our side. Any questions? So thanks.
So for the REST API, do you have a definition of that, or because I saw some?
Yeah, I can share it. Okay. Let me share the specification of the new APIs. Wait a moment. Can you see the documentation? Maybe let me share it again.
Yeah, I can't see it.
Yeah, can you see it now?
Yes. Yeah.
Yeah. Specifying 3 APIs. Yeah. This is the URI and HTTP message, and the request. The app will give the app name and app ID. And here is the example of the host information. Next, the GET service capabilities. Example of this, let me show the example. It's like this. And the PTZ control, the app will give the PTZ vectors, and the host will reply the result of the operation. Yeah, that's a draft specification. So,
is there a standardized way of publishing REST APIs? I'm thinking of Postman or something. They
not the published API.
Maybe someone else.
There is a technology called Swagger, which has been.
Yeah, that's what I'm thinking. Open API is it called now, right?
No, Open API. Yep.
So I think if we go.
Sorry, you mean the YML? Sorry, what kind of APIs you see?
The Open API is a specification for RESTful HTTP APIs.
You mean this kind of?
No, I think it's is it TOML? 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 It's either TOML or JSON, one of the two. It used to be called Swagger, but they've renamed it recently.
You mean the payload format or?
No, it's a spec.
Oh, spec. Okay,
Yeah.
I will try to find it. Okay, any other questions?
I have a question.
Okay.
For the PTZ, like how we have in OnWave, there is no PTZ spaces, wherein how you define your PTZ space, it kind of varies between the device, which does some kind of translation from, say, world coordinates to camera coordinates or something like that. But I don't see anything like that. So when you just say PTZ operation, it's difficult to understand for the camera. So
yeah,
you need something like that.
Yeah, you mean the space? Sorry, the coordinate with, right?
Yes, I mean there has to be some kind of normalized coordinates, or at least there has to be some reference coordinate system against which these requests will be translated.
Okay, I will add this to the API definition.
All right. If there's nothing further now, we'll take a break for 10 minutes. Then we're gonna have a presentation about metadata from Serum.
Okay.
Okay, we're back here. So I think Sriram, you have a presentation about protobuf.
Yes, I'll be sharing my screen.
All right.
Yeah. So can you see my screen?
Yes.
Okay. Hi everyone. My name is Sriram from Access Communications. This is a presentation about kind of standardizing metadata in protobuf format. The overall agenda looks like this. Just a quick introduction about protobuf and the objective of metadata standardization, followed by we made a quick comparison of how ONF XML stands against protobuf sample that we created, and any feedback and questions that we can have for taking the discussion further. Quick introduction of protobuf. It is language neutral and platform neutral, which is in sync with the Unimatrix philosophy that we have and the ecosystem that we're trying to build. It is an extensible mechanism for serializing structured data, which is developed by Google. It has multiple language bindings wherein given a schema and you create a specification against the schema, you will be able to generate the code on both encoding and decoding of that particular schema in multiple language bindings. I have listed the most widely used here. And at this point, I would also like to mention that there are more third-party language bindings available. I will update this presentation with that link wherein you have bindings for languages, including C, which is for our embedded systems. And another advantage we have is the code generation will have a smaller footprint, which improves the speed at which the processing takes place, and it is always like both forward compatible and backward compatible, wherein the older binaries which get a new structure, a structure with a newer data, will just ignore the new field, and it is not anything that can break the existing compatibility. And sorry, there are multiple data types that are defined, so it gives us a lot of flexibility in how we define our data structures. Going to the objectives that we have, what we wanted to see as a community is we should be able to, our cameras or our devices should be able to send a portable interface description language formatted APIs for the analytic data subscribers, and the cameras or the device vendors should be able to extend or upgrade their firmwares without having to worry about breaking the compatibility of their metadata structures with the integrations that they have already done with say third-party vendors or VMSs. So adding a new field to a structure or removing a field from the structure should not cause any regression to the existing integrations that are being carried out. And I just wanted to build a hypothetical case here wherein say if camera generates face detection metadata and you have an application that is running on-prem that takes this metadata and tries to extend that structure with say face recognition data, and we are passing it on further to the cloud component, which actually uses it as a for forensic search. So it is for such kind of use cases that the Unimatrix has come into picture, and using protobuf as a metadata transport will actually support the use case that we have as a goal in the high level. As we repeatedly see this as the goal for Unimatrix, the metadata generated on the device side, we will be able to share that with on-prem, and then it can be taken further into cloud software. And use cases, as it was mentioned from in the original slide as well, there are multiple analytics apps here for heat map, traffic control, or any VMS application that is built for integrating our metadata consumption. And we just did an analysis of how the current ONWIF metadata structure looks like. And I think Frederick, in one of his telcos, I think last week or 2 weeks back, he has shown a sample protobuf structure. We just wanted to do a quick comparison of how it is represented in ONWIF and how it can be on the protobuf. So, sorry, at a high level, are you able to see, or you want me to extend it a bit further?
Yeah, please zoom in a little bit.
Yeah, I'm doing it. Is it okay now?
I can't see it.
This is a bit. How is it? Is it looking okay?
Yeah.
Yeah. So if you are familiar with ONWIF metadata structure, there is something called as frame, and there is an object structure in that. So that can be mapped to a scene and object ID. Similarly, we have something like an object appearance and a bounding box, which we have defined in the scene object and bounding box. Some of them are some of the ONWIF metadata structures are deprecated, so I just highlighted them. But otherwise, as you can see, it is fairly simple to create the structures. But yes, depending on the use cases that we want to support as a group, this can be extended. But this is just a sample that we wanted to bring to the table for discussion, and seek the feedback from the members and see how we want to take it forward. We have something like class type, and we say it as object and a label name. The likelihood, which is like a confidence value on protobuf side. Yeah, so this is a sample, and ONWIF metadata is quite extensive in the sense a lot of license plate, vehicle, human face, human body, all these were defined in ONWIF. So we can just take inspiration from what was defined and see what is actually required on for Unimatrix as a group, and see if we can extend the sample proto that we have created in covering multiple use cases. So this is just a start of discussion, and we will see how the interest in the community is, then we will take it forward. So yeah, that's the presentation from me, and I would like to hear any feedback or any other suggestions in this. I think the sample is already shared in the group.
Yeah, it's available in the private repository.
Okay.
You need to sign in to see that one.
Yeah, so this is the sample that we have. Started with the basic structures like bounding box, point, polygon, and a vector, followed by when you say define a label, which is say after inference, we will have some class as the output. with the confidence value. And an object can have object ID, confidence, label, bounding box, and if it is a moving object, it can have velocity as one of the data. And the event actions.
I guess that's a major. The velocity. It's a difference from ONIF, because in ONIF it's only a value, right? So
yeah,
here you also have a direction, which makes sense to me.
Yeah, ONIF it is just one field as speed, which doesn't have anything with direction. So, and some of the event actions are already part of ONWIF, which is event split, merge, and delete. We can have something similar here, and say for event, which can have the event identifier with object ID and any other information required for event. And everything is part of a scene, which is similar to what we have in ONWIF. And the time, we can have time as a like NTP time or a wall time, so that it will be easy for integration with external partners like VMS or any other integration systems. So this is our draft proposal to have protobuf as a binary transport, and we would like to hear more from the members.
I have a few questions about this document. It's since points are 3-dimensional, then you have polygons, then have a repeated points. But if we have polygons with like 3-dimensional points, what would be the outcome? Because it can probably be ambiguous. Let's say how to shape that polygon, or what? Because usually in 3D you have a mesh, which is like faces. I don't know if we want to go that deep in terms of defining kind of an object in a 3-dimension.
Yeah, it's more like a field, right? If you have 3-dimension, it's more.
Yeah, and let's say usually you define a polygon with 3 faces, and then its vertices. You have a set of vocabulary, let's say, in order to build a mesh and understand that object in a 3D environment. So I see point as a 3D, but the rest doesn't follow the 3D kind of a 3D structure.
Yeah, I think probably for defining a polygon, when you're drawing it as a bounding box or the area or region of interest, probably the third coordinate may not be required. But if you see if you want to represent an object movement from say position A to position B, and then when you say a point, then the third dimension also comes into picture. So yes, I agree, for polygon it may be a bit overkill, but in general for object movement, it makes a bit more sense.
Okay, perfect. Yeah, that's the only comment. Thank you for the clarification.
Yeah, no problem. Thanks for the question.
I have 2 questions. Has this been accepted by ONWIF?
No, because we are not pushing proto into ONWIF as it, because ONWIF already has an XML representation, and I'm not sure if we want to have another representation in ONWIF. So this,
I mean, we could do it. It's just that we thought about starting here first, since
Yes.
ONWIF is more closed. So that's why I think we want to have a bit more wide discussion.
Okay. The payload type is proto buffers, and we transfer the metadata by using ITSP or use other protocols.
I think transport mechanism is not discussed yet in Unimatrix, isn't it? So, but I think right now MQTT is something which we see a lot in the discussion. So we can have MQTT as the transport mechanism, but I think it is open how we want to transfer it from, say, device into the systems.
Oh,
yeah,
okay.
MQTT is one option. Another option we have started to explore is using Dash, MPEG Dash as transport.
Any other questions?
Yes.
Yeah, sure.
I have another question. Maybe it's about maybe it's relevant, maybe not in that context, but maybe how would you interpret a scene description or tags, probably telling globally like this video is like is globally red, or like those kind of like, oh, we see in that picture, like maybe labeling like there's a car, there's a but not necessarily bounding them to a box, but just telling like overall picture what you found in that overall picture. Maybe there's some higher concept, high level information we want to tell about the what we see in the video.
So you mean to say some kind of a summary of the scene rather than the actual scene description, isn't it? Or some kind of closed caption, like captioning the metadata.
Let's see. Yeah, captioning is a good example of something that doesn't necessarily have coordinates.
Yeah.
And probably let's say your picture is globally red. Maybe it's not pointed to a specific area in the scene, but it's like the overall of the scene has been defined as a proeminence of a red color, let's say, or something like that, which is not related to a box. Let's say it's more like how what you interpret from the scene that might not be boxed. Maybe it's not a situation, but I see that in other APIs when you send a picture and they send back like information about those picture. I'm thinking about Azure AMS like API for computer vision.
Okay, yeah, that's a good use case. Probably we can have it as a discussion and see how we can extend the existing proto sample to address such use cases as well. That's a good point.
But is that more like an event, like something happened, or
it's kind of labeling, high level labeling of picture, and some will tell like there's it can be sometimes it's there's a for this AMS API call specifically, there's a redundancy. Let's say like it label high level labeling the picture, telling like in that picture there is cats, there is humans, there is a road, there is on the matrix, or a certain kind of vehicle. And so it's like high level, probably it's for fast search purposes, so it's just tags without any coordinates, and then you can, depending on the case, there can also be object with described those kind of labels or not. It's not necessarily linked together, like having like 3D, not 3D, but bounded object. Let's see.
But is the data say per frame data, or such summary is sent for a clip? For example, you have a 30-second clip and then you have a description of that clip. So kind of what is the use case that you saw where is it per frame or
okay,
a short clip of say 5 seconds, which was captured during an event trigger?
yeah,
so maybe you can present such use case in maybe next meeting if you have some example, that would be great.
Okay, yeah, that's very good, because my sample was about one picture and the analysis of that picture, but setting this to a video, it would be really relevant what you said, like an overall of the clip as a description with no bounded box makes sense. So it's a different call in that situation.
Yeah, then probably then it's not I'm not sure if we can fit that into the current scene structure, because right now scene structure is like per frame structure. So if such things have to be accommodated, we may have to have some kind of a clip kind of a structure with the gist kind of a summary that you plan to have for that. But yeah, I mean, depends on the use case. We can definitely extend that.
And one last thing I saw from API is, let's say there is a hierarchy, meaning like a tree has a certain confidence level, but it come from a higher concept, which let's say a cat and a fill-in. A fill-in, you have like a 30% confidence that is a fill-in, but like you have a parent from that object, you have a parent that you can consult where it tells like it come from a group which is a fill-in group, and this fill-in group is like 92% confidence. I don't know if it makes sense, or like this is what I got from APIs that might be useful in this one, but just suggesting.
Just a second.
Maybe for label, you have a parent, which is kind of a label too.
Okay. So is it a kind of say primary classification and secondary classification, wherein you initially say this can be part of say felon group, and if you do more analysis on that, you can end up with say a cat group. Is it like that?
I think it shows up the more specific on like as the direct access. Let's say the label directly would be a cat. Then you have with a certain confidence level, and then you can click. You can go to parent, and the parent will be a broader group with an higher confidence.
Okay.
But it's my take on that. But I'm really not into that space. So it's just by looking at other implementation that maybe there's something that we can bring to that one, that implementation too.
Okay. Yeah, I'll go back and see how we can add such things. Thank you. Thanks for the feedback. Anything else?
No, thank you very much.
All right. 5-minute break.
Okay, thank you. Thanks for your time.
All right, we're back. So next on the agenda is an update from Kevin about CubeEdge. Kevin, are you ready?
Yes. Can
Great.
you hear me?
Yes.
Okay, let me share my screen. Okay. Can you see my screen?
Yes.
All right, so I will give some updates about CubeEdge. Briefly, I won't go through much details about the background. So just to give some reminder here that CubeEdge is built on top of Kubernetes, and we are actually using the managing nodes on the edge. So to achieve a lightweight format, managing the resources on the edge. So here are basically the highlighted capabilities CubeEdge trying to provide. The architecture, we didn't make any change since last time introduction, so I also won't go through the details. So I want to repeat here is that the model CubeEdge trying to build is that especially in the cloud, we have some plugin to being stored to a vanilla Kubernetes cluster. So turning the cluster able to manage both cloud nodes as well as edge nodes. In the edge, we actually besides lightweight kubelet, we introduced the node level metadata persistence to make the node able to work autonomy when it's disconnected from the cloud. And also we implemented the standard interfaces, for example, container runtime, network, and storage. And also for the IoT devices on the edge, we have a device protocol adapter, or we call it a mapper layer here, to simplify the application development, especially when it's communicating with different types of IoT devices. So inside cloud component, what we added recently is that a new model called sync controller. This is to actually improve the consistency between cloud and edge. So it will detect the inconsistency faster and trigger reconcile or retry in a short period of time. Others are the same as we last time introduced. So the edge node components actually are the same as we last time introduced. We have the lightweight kubelet and also node level metadata persistency, and we have the edge hub to deal with the communication with the cloud components to make it able that the edge node can be working behind a firewall or inside a private network, so it doesn't require public IP address. So key features added since last time was that the first is just as I introduced, we improved the message delivery reliability between cloud and edge. So now when CubeEdge delivering the message, we have a fast loop and a slow loop. So the faster loop rely on the ACK message from edge node to make sure it's up to date. Otherwise, it will retry a few times. And in other cases like disaster or disaster recovery or other much more critical situation, the slow loop will periodically check, compare the data between cloud and edge, and start reconcile to make sure the data between cloud and edge are consistent. And also we introduced the component config API to simplify the installation, actually the configuration of QBage components. And also we introduced the API versioning, so make it easier to track the changes of component config. For the node automation, that's useful for especially the users to adopt QBage. So we make it now able to automatically register a node when it's first time connecting to the cloud, and also introduce the automated TLS bootstrapping. So when QBage starts, it will automatically generate the certificates and enforce the TLS. So then the admin doesn't need to do it manually. And for the next release 1.4, we will provide automated certificate rotation between cloud components and edge node. So make it much easier to maintain the whole system. And we also improve the cloud component high availability. So in previous release, the cloud core actually rely on the Kubernetes deployment to make sure it's alive and serving. And with higher availability introduced, Cloud Core is able to switch to a hot standby in a very short time to reduce downtime in any disaster cases. And also, we are improving a lot of features to help operating and maintaining the system. So edge pod logs is to simplify collecting pod logs in the cloud. So the developer and the admin can just need to execute the vanilla Kubernetes logs command to get the and he's able to get the logs from the pods located on the edge nodes. And also metrics are working in the same way. So in the latest release, we added interface on the edge. And for 1.4, we will provide the whole stack of the implementation to make user able to collect the metrics data in the cloud. And also we will provide Prometheus integration in 1.4. So another big improvement during this Montes is that actually we provided more integration support to open source container runtimes. Alternative to Docker Containerd, we currently also offering CRIO integration. So CRIO actually can save 40 more megabyte footprint than Containerd. And also for the other case have much more security requirement, we also offer Kata containers integration. So here is just a very brief summary about QBage development requirement study. For the underlying hardware, we recently verified and automated the ARM64 support. So previously we are mainly running tests on x86 and ARM32. For the footprint, we didn't do we not yet do improved much. So for the full-featured installation, it still need 70 megabyte memory, and also to for resource-restricted cases. Currently, the minimal footprint is 50 megabytes, but we got a footprint reduced from the container runtime. You can see if the end user choose to use CRIO, this is another standard container runtime. It will save much more footprint than containerd and Docker. And also, actually, I also like to know the actual more details about requirement from Unimatrix, so we can better set up the plan how to optimize the footprint for the resource restricted cases. For Kubernetes capabilities support, we currently support the main Kubernetes releases, and the 1.18 will support will be provided in the coming 1.4 KubeEdge 1.4 release. Okay, that's brief about technical updates. So I also like to highlight the KubeEdge community growth. So since we actually donated the project to CNCF in March 29, and the community and the project is growing under a very high speed. So you can find out the the number of contributors grow 10 times. And also we currently have 14 maintainers from 5 different companies. And also the contributing member organizations, we currently have more than 25. And for the cross-community collaboration, the ongoing are we are very close working with the Kubernetes IoT Edge working group, and also for Acrino. Currently we have a blueprint family under Acrino, and the first blueprint under development of this blueprint family is the machine learning inference offloading. So this is basically to the assumption is that the edge always have limited resources. So in cases that the application need to do more complicated inferencing, it can offload the requirements to the cloud. So make cloud and the edge coordinate together to cover both simple cases and complicated cases. For the contributing organizations, I'm just listing some of the well-known companies here. So we have the IoT and hardware companies in the community, and also we have the telco operators, and also the IT service providers, and also cloud providers, and we have some academic contributors from China. But basically, we currently are building a global community. So you can find out actually we have the contributors from China, India, US, and also Europe. And also the big growth during these months is that we are getting a lot of our users to publish their use cases and also publish their names. So I won't go through many of them, so just want to highlight one of them. So this is a use case to help building the electronic tolling system in the highway in China. So they have their toll system in their on-prem cloud environment, and also they are deploying and managing the applications with the system in the public cloud. So currently, the main application is the inferencing application to detect the vehicle vehicle number plate, and to do the automatic tolling. So on the edge, actually, these are located in the ETC gates or ETC stations. So basically, it's toll stations. So this system is to replace the past manual tolling. For the hardware on the edge, currently they have a few industrial PC based on x86, and also the majority are ARM CAN servers. So in total, currently the whole system, they are managing more than 50,000 edge nodes. So actually these are done by multiple QH clusters. The containers in total currently are more than 500,000. So the records every day is more than 300 million data records every day. The end-to-end benefit is improved the time passing through the toll station. For the car, it's improved from it's optimized from 15 seconds to 10 seconds. For trucks, it's going down from 29 seconds to 3 seconds in average. So very impressive improvement. Okay, so so actually the more use cases are available on QH website. I'm not going through all of them here. And for the roadmap, from the technical aspect, we will in the follow-up few months, we will continue to improve the usability, stability, and the security. So basically, we will provide the metrics capability in the cloud, and also we will provide the cross-subnet communication functionality for applications located in different edge, especially located in different private network. And also we will improve the framework extensibility for IoT devices, and also we will improve the whole platform extensibility. So the details, the detailed roadmap, you can find here from the link attached here. From the community perspective, we're targeting to get more wider user adoption, and also get more developers to join the community development, and we will do more evangelism. For the governance, we this year we are going to set up SIGs. So SIG is short for Special Interest Group. It's kind of a working group in many other open source community. The first three SIGs to be started are device IoT. So this will focus on building the general functionality for better integrating with the industrial devices. The MEC SIG will collaborate telegos and also the some of the working group relevant in the other open source community to provide a reference architecture and the implementation that using QH to enforce the 5G and MEC business. For the Edge AI, currently it's more relevant to the under development Arduino ML offloading blueprint. So we want to keep identify the requirements from AI users and platforms to improve QH to better serve the business that using AI capability on the edge. Yeah, that's all about the updates. The demo, we are still setting up the hardware, so not yet able to do it right now. I will probably share a video record later on, maybe next week. Okay, that's all about the updates. Any questions or comments?
So what's the difference between the minimal and the full version?
So actually, QH, because currently it's developing a general infrastructure layer for the different cases. So some of the components are not necessary in all the scenario, like device. So for example, here the minimal, the device string and the event bus, that's more relevant for the IoT cases. So in the minimal cases, this might not be required. So this one is not started, and also edge mesh is not started, and also monitoring, because the user may have their own monitoring implementation. So basically, the minimal setup for the Edge core is Cloud Hub, Edge Hub, metadata manager, the node level metadata store, and the HD.
So is the broker always packaged, or is it also something you can supply yourself?
Sorry. So
because,
the.
Yeah, I remember when we tried it in December, it was including a MQTT broker in the edge.
Yeah. So actually, we have a built-in MQTT broker, but you also you are also able to disable it. So the difference is that enable, disable, it takes different footprint, but the the binary size are the same.
Okay.
And also users are able to use if they have their own MQTT broker, they can use their own. So we have the actually the different mode to for the in the configuration to indicate whether a user want to use the built-in broker or disable it or use a external broker.
Okay. The edge mesh, that's, I guess, a service mesh, right? So is that a standard code? Are you using Istio or is something else?
So edge mesh here is actually not just the service mesh, but also it's covering some of the networking functionality. So if you need the service functionality, currently one challenge is that the DNS recording provided by DNS functionality provided by Kubernetes is centralized by default. So HMesh is providing the node level domain service functionality. It make it able to work when it's disconnected to the cloud. And also, if the user don't require much functionality of the container networking, HMesh also have a built-in fallback solution to deal with pod-to-pod communication through the host network.
So this full version includes the edge mesh.
Yes.
All right, that's pretty impressive.
Okay. Hello.
Yes.
I have a question. When you say device twin syncs the device status between cloud, what exactly is the status sync? What is it actually syncing?
So actually, the device, device like the IoT devices, they have some of the properties, and also like the so maybe you have a switch or kind of the other device like some lights. You can use the device twin to change the. So the device twin need to work together with the device API provided by KubeEdge. So end user can make a change on the device API to set a status or set a switch of a device on the edge. So the device twin here is to so in the cloud the device controller will reflect the API change to send the message to the edge. The device twin will persist the API change in the edge node, so make it able to recover when it's disconnected to the cloud. And then it will also send the update to the actual device, and the device can reflect the change, like turn on a light or turn off. Or also it can be used to read some of the properties or data. But if you are integrating with some of the industrial sensor, there's a lot of massive data. We are currently under development to integrate with some third-party project to do some software filtering and regenerate a useful data, then make it send it to the cloud.
Okay, so if there is some configuration change that is triggered from cloud, it first updates the edge store for the configuration, and then the device twin sends that configuration change to an edge device.
So actually, there are two directions. If the user wants to change a device switch, they can just change a device object, and then the device controller will send the change to the edge, and the device twin will first persistent the change on the edge and then send it to the device. Another direction is that some of the status change from the device, then the device twin will also persistent the change in the node and then send a copy to the cloud.
Okay, there is an event bus here, and in the first diagram there is a mapper. So is event bus same as the mapper, or is it something else?
Oh, so no, actually the event bus is to talk with the MQTT broker. So mapper actually is more like a protocol converter or protocol adapter. So when integrating with different devices, the devices may have their own protocols. So mapper is to convert the protocol to MQTT. So for the application developer, they can just rely on MQTT. They don't need to worry about the actual industry protocol.
Okay.
So actually, the path will be device twin or a application talk to the event bus. The event bus talk to the mapper through MQTT broker. The mapper will talk to the actual device.
Okay. Okay. Thanks.
All right. Any further questions? Otherwise, we'll go to Focal's presentation.
All right. Thank you for your time.
Thanks, Kevin.
Can everyone see my screen at this time?
No. We saw it. I saw it briefly.
Okay.
Okay,
there we
now
go. I think I got it back. Great. Thank you all. I'm excited to give this presentation. It's been a busy couple of months in the background, speaking with many of the contributor teams. We've collected a lot of that feedback about testing and are here to discuss CI/CD for the Unimatrix project. And if you're not familiar, CI/CD means continuous integration and continuous deployment. And so just as a bit of background, right, you know, I think the CI/CD tooling of the modern era as it stands, which I'll kind of describe in detail, really owes its popularity to JavaScript applications and to the web in general, right? So this is very much a set of technologies that were adopted and enabled because of, kind of the SaaS boom of the last, from basically the advent of the early public cloud until now. And so, a lot of words get spent on Agile and all the tools around it, of which, CI/CD tools are certainly one. But, what at the end of the day, what is this really about? This is about a group of stakeholders in a particular business demanding that features get released much more quickly, almost on a daily basis. And so once the operational ends of these SaaS companies were in a position to heavily leverage the cloud, that really put the onus on engineering to enable that daily refresh of features and that overall quote unquote agile search for those sticky features that are really going to drive business revenue. And so what you saw was quickly the line between engineering and operations got blurred. You saw engineers who were much more operations facing, whose job it was to deploy code into production. The DevOps, the DevOps name got coined. And from there, the same thing that happened in every other business vertical at the time happened to engineering tooling, which is it all. The opportunity got discovered, and it all went online and became SaaS tools. And so that really is kind of the 2-minute version of why we have CI/CD these days. And so I'll show you just a little bit of kind of CI/CD pipelines in practice. So this is actually our CI/CD pipeline for some of our Python API, and you'll note that it's a pretty simple 3-stage pipeline. With GitHub being really the trigger for the CI/CD service, which in this case is Circle CI up there at the top, to containerize, build, and unit test our services. Those Docker artifacts that get pass those initial tests are then integration tested on a real GCP Kubernetes cluster running out there, on GCP in the wild at a URL that no one knows but us. At that point, we can load test it. We can, chaos test it. We can do all kinds of things to verify that it's working as expected and that usability is there for the end web clients and end programmable API clients. Those artifacts that pass tests end up in a production registry, and the pull to deployment is gated by an executive decision by myself or our engineering manager. And then we basically replicate the deployment process, or sorry, the integration testing process. We just replicate it in deployment. So same service fabric. We just deploy the same artifacts, and the service is up and running at our public URL. So a couple of interesting things to note here, right? So first of all, in the build step, right off the bat, for interpreted languages, for JavaScript, Python, and related, right, you have this very nice set of mechanisms for binary dependency resolution that are kind of baked in. In Python, it's pip. In JavaScript, it's node. Secondarily, right, you'll note that for the most part, simple logging suffices here, right? You're not really concerned too much with real-time constraints on logging. You're not really concerned with logging large chunks of binary potentially. You're really just concerned about very compressible text, and you don't even care that much if it if it's anywhere near real-time delivery of that simple text, because at the end of the day, your CI/CD service and your testing apparatus is collecting those logs, and you're only going to review them if something's broken anyway. Third, right, we've got a staging environment that is identical to the production environment. And then, of course, sort of the key magic of the cloud these days, which is, automated provisioning, more or less a single hardware architecture under the hood, and latency-based auto-scaling from technologies like Kubernetes. Kubernetes also does a couple of nice things with respect to green-blue deployment, and what that means is that you deploy something, and the artifacts that were previously deployed but are still servicing requests are sort of gradually phased out. And so all of these features in total are really quite beautiful, and the workflows are elegant and clean, and the services work well, and everything is great. But cameras aren't agile, right? So the motivation for our discussion today is really this issue that this similar kind of service architecture doesn't extend easily out to the edge, and in particular, edge to cloud services are really challenged to define similar kinds of CI/CD workflows. In particular, because of air gaps in the system around firmware loading and a host of other issues that I'll get into shortly. But overall, what I wanted to really talk about here was not that, that the killer app of CI/CD is not, is not really this whole agile thing. It's a bigger idea, right? And so that bigger idea is situational awareness, right? So basically, everyone in the management chain who uses CI/CD as the sort of the key backbone of service delivery kind of has a shared awareness of the state of the application. All the stakeholders understand where things are at, which features are testing appropriately, which features are in release, and what the what the overall pipeline looks like. It sort of defines a meta artifact that everyone can get their heads around and everyone can understand, right? So this, this reflection about situational awareness, and this is a particular term that comes from my background with DoD projects here in the U.S., led me to think, okay, well, if I were going to really take this from a top-down perspective and try to think about situational awareness for the Unimatrix project, what would that look like? So, first of all, who are these stakeholders, right? Well, we've got the key contributors to the project, obviously. We've got the hardware OEMs whose hardware ultimately the stack is going to run on, and we've got the application developers who are going to consume the stack and deliver end applications. And so in that context, I came to a very opinionated, expansive definition of situational awareness, right? So this is really kind of the centerpiece of the talk, right? It defines situational awareness as sort of a single set of meta artifacts that represent kind of the state of play for the Unimatrix stack amongst its applications and amongst its target hardware devices. And so you'll see here, frame rate represented as kind of the key usability metric. Obviously, there are many more usability metrics that we might care about, but this is the one that everybody cares about in image and video processing right out of the gates. Other metrics to consider are jitter, throughput, size, weight, and power, things of this nature. But in general, in my mind, a kind of a very holistic top-down view of which devices are benchmarking well against which applications, which devices are broken for which applications, and overall, importantly, you'll see those pluses and minuses there, how that overall view of the space is changing with each commit to the core Unimatrix code is a really important total understanding of the space and of the state of the project. So again, highly opinionated and expansive definition of what it means to have total situational awareness across the Unimatrix, the set of Unimatrix stakeholders. What I want to say here, right, is that I've been on a lot of big programs over the years, and really this kind of top-down view of the state of play truly defines what T&E should be pursuing. And in my opinion, test and evaluation is about producing this meta artifact. It's about producing this top-down view for everyone, so that we've been discussing here these last few meetings the idea of forming a test and evaluation working group. Ultimately, in my opinion, the directive for the test and evaluation working group should be to produce a very high-level, comprehensive view of the state of play for the Unimatrix ecosystem of the kind that you see here. Granted, this one's a cartoon. The real one would obviously be a lot more detailed, but I think you get the flavor, right? So you've got a couple of key scaling dimensions, namely the benchmark applications, the device set that we are officially supporting, and finally the key metrics along which we are benchmarking. So quite a big search space for us to cover. And so in this light, with this kind of expansive view of T&E in place, from there, I want to talk just a little bit about what we've done so far to start to think about how to tackle it. So the T&E working group I have now defined as the Situational Awareness Committee, right? It's our job to really drive that sense of a clear picture of the total operational space for the project to all those stakeholders. And so what did we do in June? We went out and we did a requirements study. We interviewed the OEMs. We did some review of the docs, and we brought a bunch of domain expertise to bear on the study. And the results were obviously quite skewed in favor of the OEMs and their chief concerns. But I think these concerns are important and relevant nonetheless. So number one, obviously, we've heard a bunch today about how hardware requirements are a major concern. Is the hardware going to be able to support the Unimatrix stack, the hardware from each of these vendors? Furthermore, what are these unknown unknowns around Docker and Kubernetes going to do to the overall performance of the target applications? And finally, there's been a lot of talk today about networked operations, particularly with regard to the APIs and the API specs and RESTful API transport between servers and clients, as well as gRPC flows of the same kind. And so there are a number of concerns about overall quality of service and reproducibility where network in the loop is concerned. And just looking back on my career, having participated in a number of big image and video processing programs, these are not new concerns to me, right? These are the kinds of things that one would expect going into a large T&E effort involving many vendors and sort of moving targets requirements as the scope of the program grows to address more and more hardware and more target applications. So my goal from here is really to talk about what we can do to kind of enable sort of a successful mitigation of these concerns for each of the the major stakeholder groups here. And so my overall opinion is that, and we've just just presented our opinion to the governance board with regard to how to tackle the problem of the hardware OEMs and support for adding support for hardware. But my kind of one of the big takeaways here is that ultimately, based on what we've seen in a number of other projects, the ability to add support for hardware is one of the key rate limiters of adoption throughout the open source ecosystem. So the moral of the story there is that if you have a good pipeline for adding hardware support, you've got good T&E procedure around adding hardware support, people tend to adopt quickly. Whereas if hardware support is not well organized and there isn't a good pipeline and a set of processes for adding hardware support, adoption is for these open source technologies is actually quite slow. And so we think that due to the slowness of adoption, it's important that we go ahead and get the CI/CD pipeline in place to address growing the hardware support base quite early on. We would love to hear feedback about that in the questions. Now, obviously, the second group there, the Unimatrix contributors, has a hot need right now, right? These are you all in the peanut gallery at the moment, working on your projects and on your contributions. And there are a bunch of open questions about how to test this stuff, how to make sure that it all has good interop, and how to harden the code base so that the technology is primed and releasable at a fairly aggressive cadence starting in 2021. So again, we need to start thinking in a serious way about implementing a T&E regimen and an associated CI/CD pipeline for the contributors. And finally, application developers, I think, given how much work there is to do here already, it's safe to probably punt and say, okay, we will worry about how to provide testing infrastructure for application developers later, more down the road towards the version, maybe the beta version or the version 1.0 release. But in the short term, again, top line is that due to the speed of adoption on the hardware side, we need to think about the hardware support pipeline and the support pipeline for core contributions to the stack. So moving forward, we'll call this these specific recommendations CI T&E because we aren't actually deploying anything, right? At the end of the day, what we're trying to do here, again, is produce that very high-level map of the space, that meta artifact that lets everybody kind of understand the state of play for the project. So jumping back to the typical CI/CD pipeline that we saw before, right? What do we see here, right? I highlighted a bunch of nice things, right? But do all of these nice things apply to our problem domain? Well, sadly, no, right? First of all, binary dependency resolution has a bunch of ABI incompatibility issues when you start to introduce multiple hardware architectures, even down to which compiler you use can influence the ABI, and so you really need a solution to this ABI incompatibility problem. Without it, you can't do automated binary dependency resolution, and development workflows get pretty annoying. Obviously they're not insurmountable, and you can always hand tool your Docker containers to account for this, but then you get stuck with sort of bad namespacing solutions and renaming things, and all the gobbledygook that all engineers hate, but tolerate. So, there's one question there: is there a better way to deal with binary dependency resolution in development workflows? Another really important issue here is around logging, right? So obviously, with real-time applications, video processing being a prime example, we can't have lazy logging. We have to have logging that has access to hardware counters. And that's really the gold standard, is being able to get those CPU counts back on a per cycle basis, and to understand how long computation takes, how long frame ingress and frame capture takes, how long how long data egress takes. Really getting hard, real-time oriented metrics to key events in these image and video processing pipelines is absolutely critical. Again, we talked about how the staging environment and the production environment are identical for for these very simple web applications. Obviously, that's not going to be true here even a little bit. At the end of the day, the production environment for the Unimatrix code is going to be, on the side of a building somewhere, watching a crowd of people do things in the real world, right? And there's going to be real lighting conditions and all number of difficult, hard to reproduce phenomena that we need to think about testing for, nonetheless, in these early stages of the stack's development. So I'm going to put that more on an application developer problem, and again, that's one that we're going to punt on here. So stay tuned for more thoughts on that, maybe at our next hackathon, but for now, I'm going to set that one aside. Importantly over here, right, cameras are not virtual machines, right? So you don't get magical automated provisioning, and you don't get to just assume that everything has one single hardware architecture, and that in and of itself it relates back to our ABI compatibility issue. And finally, obviously performance can't just be magically scaled, right? You don't just get to say, okay, Kubernetes, like, figure this performance issue out for me, right? So we really need tooling that addresses performance engineering use cases inside of our CI/CD pipeline from day one, right? We really need to get to the bottom of performance when there are issues, and I'm going to outline some strategies for getting that done. So here are the specific recommendations that Focal has been working against ourselves internally for these kinds of use cases for the last 18 months, roughly. If you're not familiar with Conan.io, it is it's basically a package manager for compiled code. It is a front end to a number of sort of build systems. It provides simple wrappers for CMake and a bunch of other nice things. You name it, there's probably a Conan.io plugin for it. I'll talk more about that in a minute. LTTNG is the Linux tracing toolkit, next generation. It is it's a very robust, highly performant tracing toolkit that attempts to be an umbrella for a number of sort of disparate technologies, including Linux perf and user space tracing, and it even deals with Python in a very nice way. The implementation is highly efficient, ring buffer implementation, and a client-server architecture, so that you can get the traces off of the board to a server somewhere for data management purposes. And finally, the main thing that we've taken on as a company, building a device farm architecture that allows you to quickly spin up and spin down devices with completely fresh operating system images, just like you would on a virtual machine on GCP. And we've worked hard to make those workflows, actually, pretty sane and pretty enjoyable. We've got a software release coming up here at the end of the month, and we're excited to share some new sort of key workflows with the group going forward. So let's talk a little bit about what we've implemented so far. So back in April, we did some, we made an initial presentation where we actually built out part of the CI/CD pipeline for the Unimatrix project. We only treated a couple of the key repositories, namely the initial Yocto build repository. But overall, what we did was we used, first of all, we moved that repository to GitHub just for convenience, because that's where we keep all of our code. So we forked it, moved it there. We hooked our own Circle CI account up to it, and we were effectively building the Octo base image on CircleCI's Docker engine. And then the egress to that was a staging registry on Bintray. So we weren't pushing the Docker images out as our post-test artifact. We were pushing Conan packages, and so Conan has a really nice set of hooks for existing binary archives. So you can build the package. It hashes the package according to its in terms of its ABI compatibility metadata, and then pushes it up to Bintray. And so if you're not familiar with kind of these key C++ development workflows that involve a system like Conan and a binary binary artifact registry, I really think that that needs to become a key piece of the Unimatrix toolkit moving forward. And so from there, from Bintray, we were able to pull down those compiled Yocto images and basically spin them up on the fly on Focal's device farm using Raspberry Pis. We tested against both the Raspberry Pi 3B Plus and the 4B and had good success there. And so things left to do include actually implementing like rigorous unit tests for that, as well as integration tests, and then a gate to a production registry. And so again, this kind of goes back to how do we want to deliver the Unimatrix technology? Do we want to make it a sort of a key directive for the project to deliver device images that end developers and end OEMs can pull down quickly and start working with immediately? If so, then CI/CD and this kind of egress to a production artifact registry is really the answer. This is the right way to approach service delivery and delivery of our technology to the developer public and to our friends in the OEM ecosystem. If not, maybe we're happy with just having a bunch of source code and a bunch of repositories. But I think again, taking a very expansive, opinionated view of the space, that it's really our job to provide kind of these key workflows that make life easier for the folks who want to consume our technology. And so again, what can we do right now? What can everybody on the call right now do right now to kind of get a jump on being CI/CD ready? Those things are, get to know Conan.io. Start using a package manager for C or C++. I don't care if it's Conan, honestly. Conan just happens to be the one that we like. There are a couple of alternatives out there. But this sort of workflow that allows you to share binaries quickly and easily and to guarantee ABI compatibility, even across different compilers, and kind of manage your build recipes is a really critical kind of new piece of the C and C++ toolkit. And then secondarily, start getting a sense for the requirements around using LTTNG. So, for example, OpenCV has its own legacy built-in set of trace points and tracing mechanisms. The problem with those, right, is that they don't, they don't play nice. They're not part of an umbrella framework. They don't give you access to, to the key hardware counters under the hood running your OpenCV pipelines. You really want something that is strongly connected up and down the stack all the way to the hardware. And LTTNG, those guys have, they're a group out of Montreal. They've worked super hard to kind of make really sane, developer positive choices about how tracing can and should be implemented. There are a couple of drawbacks to LTTNG that Focal's been working to mitigate over the last year or so. One is the binary formats that the LTTNG stack delivers are they're very dense, right? And so you've got to go through this whole binary unpacking process in order to actually analyze the system traces, which can, based on the size of the system trace and the number of things that you're tracing simultaneously, can actually be quite large. So you're talking about multiples of minutes to kind of unpack these multi-gigabyte system traces. So that's one issue that we're working to mitigate. And another is, you heard a little bit earlier about extended Berkeley packet filter. eBPF is quickly coming up as a really important set of technologies for addressing similar use cases. Maybe addressing them in a sort of a more live context than a tracing toolkit like LTTNG can. And so it's a little bit unclear how eBPF is going to play with a tracing solution like LTTNG. But we're focus tracking those, and again, over the course of the summer, we'd like to kind of show you what the big picture could look like here in terms of system tracing. So I think that's it for me. Those are my recommendations as the guy who's obsessing over T&E and testing workflows and CI/CD for the Unimatrix project, and I'm happy to answer any questions. Thanks. Cool. If there's no questions, I'll go ahead and hand it back to Frederick.
All right. Thank you. Then next, I don't know, maybe we'll just take a short break. Then let's take 10 minutes. So quarter past 4, we're gonna start with the technical board meeting. Okay, we're back. So next is the TB meeting. I'll try to keep this brief, so we basically only gonna try to get a vote on the things that is in the agenda. So this is the agenda for today. Can you see it?
Yes.
Yes, we can see that.
Okay, thank you. So first is the charter. We discussed this briefly last TV call. So have you been able to study it? Do you have any objections? So can we take a vote on approving the charter? What about from Hikvision?
Yes. Approve it.
Huawei?
Approve.
Panasonic?
Approve.
Genetec? Sebastian, you still there? I don't know if he's muted or wait. I think we need his vote to be because the quorum actually requires us to have at least 5 members voting for approving charter modifications. So if he's not present, yes. Hi, Sebastian.
Yes, I was doing my my lunch. Sorry, I'm not. I don't know if you were talking about me or.
Yeah.
Okay.
No, we were so we were taking a vote about approving the technical charter.
Okay. Good.
So do you have any objections to the charter? No. Or can we approve it?
No. Yeah, absolutely no.
Thank you. All right. So next item is the contributing guidelines. So the guidelines right now is quite simple. I don't think there should be any really controversial here, but as we can certainly update this with if we want any coding standards or other information about how you go about contributing to the project. Can we approve the contributing guidelines as it is? Hikvision?
Yes.
Huawei?
Yes.
Panasonic iPro?
Yes, I approve.
Genetec?
Yes, I approve.
Okay, thanks. Next one is maintainers. So my suggestion is to the ones that are on the board will become maintainers for the project. So that's how the charter basically sets it up. So the question is which projects. We have a number of different projects now under the group. So my suggestion is that the TB will be maintaining the governance project, the meetings project, the presentations, the containers, and private. Are there any other projects that you believe we should be maintaining, or the other ones are more like testing projects at this point? Is that strategy acceptable? What about from Hikvision?
Yeah, yes.
From Huawei?
Accepted.
And Panasonic iPro?
Yes.
And Genentech?
Yes.
All right, so then I will make all of you maintainers for this project, and the other ones, that are currently the ones that are maintainers will remain to be that. The next item is the video API. So my suggestion here is basically to form this video working group that will come up with the specification and also the layer structure and so on, the technical details that are. So I don't think we have to discuss all the technical details again here now. Just I want approval for forming a new working group. Is that okay, Hikvision?
Yes, it's okay.
Huawei?
Yes.
Panasonic iPro?
Yes.
Genentech?
Yes.
All right. So then I will set up a new series of meetings for the video working group and some goals that we will. So I think this will maybe be a temporary working group that with a certain goal, and then just to get things going in this realm. All right, so next agenda item was the inference API. So my proposal is to make Lara the official Edge API, and then we will we'll have on top of Lara, we will have the TensorFlow serving API. So is that acceptable with the Hikvision?
About the second point, make TensorFlow serving official net. So just for if we have any other runtime, inference runtime, what does this mean? Make TensorFlow so.
TensorFlow serving is a industry standard API that TensorFlow provides.
Yeah, if the inference runtime is different, so it also need to implement the TensorFlow serving API.
Well, if we make Lara the inference engine you can implement on top of Laravel other APIs. So my proposal is to implement the TensorFlow serving on top of Laravel as a for doing inference from another node. It's a network API basically. It's a REST API, or it's a gRPC API, or it's got both gRPC and REST, which means you can call it from other nodes.
The API is between the landlord client and landlord server.
Well, if the client is outside of the device, it needs to use a network API. If the client is on the same node, then it can use Laravel and have a zero copy transfer.
Yeah, maybe I need time to discuss with my colleague and then get back and make a decision.
Okay.
Okay, thank you.
So I guess we'll get back. Anyway, any comments from Huawei?
For the Laravel as the Edge API, I need to ask about Kevin's advice, and for TensorFlow serving as the official API, I need to think about with other colleagues, I think.
So Kevin, you have any input?
Maybe probably he is not online now.
Okay.
He is mute. Okay.
Okay, I guess we have to prolong this voting one more time. We discussed this last time, but so I would like to come to at least for point 1, come to a conclusion about that. Point 2 is not as critical. So we'll defer it to the next call. My last point was orchestration. This is basically in the first slide I did this morning. I had a couple of different alternatives around deployment and how to run the apps. So the question is which ones we should choose. Here it is. So at least for Axis, I think running the kubelet in the device is not viable right now. So I think we will probably support the first one with Containerd. That one we basically get for free. The next one is also possible without putting anything extra in the camera. The third one could be interesting. So I think for us, I think we will try to support that one as well. Are there any comments from the other members from Hikvision?
From Hikvision, I think the first one use the container D API directly maybe it's too difficult because if you use the container D API, you have to deal with the image layer. So it may be difficult to implement because if you want to decode the imagery layer, you don't have you need to decode the you need to decode the OCI formatter.
Yeah.
Maybe use C. Maybe use CRR interface. Maybe better. Maybe.
Yeah. Any comments from Huawei?
From Huawei side, we should probably recommend the Cubase as the mandatory for the most scenarios. But just for the limited resource device, maybe Cubase still needs some optimization. So, but for the VMS and for the Edge, Cubase would work very well, I think. But for the limited resource device, maybe it's not mandatory. That's my yes. That's our ideas. Yeah.
Yeah, I think we can maybe define two different kind of devices. When.
Yeah. That depends on the resource of the different kind of device and the different scenarios. I think maybe we can separate the definition of scenarios based on different device or edge or the cloud or the VMS.
Yeah, I think we should have maybe two different scenarios with also thinking about the container layers. So try to make a really small layer for the resource constrained devices, and then for a more capable device, you have more full-blown capabilities of orchestration, also maybe Python and so on.
Yeah.
I have a question for CubeEdge. Does it interact well with like a major vendor like AKS or AWS?
At least with AWS, it works well. We tried it last time.
Oh,
I remember.
Awesome.
Yeah.
Okay.
I haven't really tried it with Azure, but I expect it. And there is a component. So it's not a vanilla installation. You need a cloud core component on the cloud side. Maybe Judith, you have more insight on these things.
I may not. I may not further since for the details, we maybe we should invite Kevin for the experimentation, but it seems he's not online now. For questions, he's available for the mail, and could you send the questions in the member mails to Kevin?
Yeah, sure. Okay, will do.
All right. Any further comments from Panasonic?
Sorry, I don't know well about the orchestration, but I have a question. Can we select several of them as an optional? Probably they don't have compatibility. They cannot be optional. But if some of the cases we can choose several items as optional, I'm wondering. I'm sorry. Do you have any opinion about this? Someone?
I mean, optional things should not be a problem, right? It's only mandatory things that potentially could be a problem for someone. If you make QEdge mandatory, it could cause some devices the footprint may be too big. But an optional, if it's optional, it's not a problem, and you can certainly support many of these mechanisms at the same time if they're optional.
Yeah.
The question is more for from let's say an management. How do you want to manage your application? Is it through Kubernetes, or are you because I think, at least for us, it's not that common to manage workloads on the camera itself with Kubernetes. Kubernetes we are mostly using now in the cloud only, or maybe some on-prem servers, things like that. But I think it will move down to the edge more and more.
We are currently seeking about like a different approach for orchestrating upgrade and how we distribute the application to different devices according to affinity, maybe models, regions, and other affinities like that. And we're seeking solutions, and we looked at Rancher, which is a company that is a global cluster management, where you can have like affinity pools and define where you want to distribute some containers. So it looked like it's a good approach for us for management of what's installed at the edge. But so far it's the best approach, but I see that the payload might be a problem, deploying on the edge those kind of orchestration clusters. It's key trees, the product on the edge. So it's kind of a complementary package, but it has a footprint. So maybe it's not a good use case in a Unimatrix scenario. I have to dig with the Rancher company to see how it would, if it fits or not.
Yeah, K3S, we also looked at it. It's the problem with it. It's really the packaging is compared to Cube Edge, which is really optimized for Edge. K3S is it's both the master and the kubelet in same package. So it's more if you run the whole cluster on the edge. So it's more not really our use case, I would say.
Okay.
So I think Cube Edge is more suitable for when you have a master in the cloud or things like that. While K3S is more for having the whole cluster.
Yeah, I would really like to see how our orchestration work on the Cube Edge. That would be interesting, like from the cloud point of view. Ansible also is a good tool. So my choices are around those two.
Yeah. All right. So I think we don't have to take a decision about this right now. So I think we can defer this discussion. Any other comments? Any other business? Because that's the next point. All right, then it's been a long day, so I was meaning to do a presentation about how you can do the code sharing and so on in Visual Studio Code. So if you think that's a good idea, I can do that right now. So basically, for tomorrow's hacking task, I will just give a short demonstration of how you can use Visual Studio Code to share your workspace. Also, there is a new tool from Microsoft, web-based, called Code Spaces. So basically, it's a Visual Studio Code in your browser. It's still in preview, so it's not released yet, but it's possible to use it. So I will just do a short demo about Visual Studio Code and how you can share your session. So you just install Visual Studio Code from the links I provided in the agenda. You can start up your Visual Studio, and then you install. Here is a number. Here you can install a number of different extensions. So you need to install the Live Share extension and the Live Share audio extension. And when you have installed Live Share, you get this little icon called Live Share. And then you can start a collaboration session. Then you need to sign in to an account. So either you can use a GitHub account or a Microsoft authenticated account. I will use my GitHub account. So you need to authorize in GitHub that live share can use your account. All right, so now we are started. So it tells you that it's copied a link to your clipboard. So then my idea is to use Slack to share these links. So we go to Slack channel, to general. So just put something there. So now you should be able to join that. I will join my own link here. That's also possible. So now it started a new Visual Studio Code. So now I join my own session. So I can do modifications here. And it should be visible in the other one. Yeah. Also, it should be possible to join using the. I can show. Yeah, you have a session chat. So here you can chat with each other. Also, you can do an audio call. So each one has. Then it connects to the same audio channel. So if you connect here, everyone has to connect with audio if you want to chat to each other. Also, it's possible to join using the web. I will try that now. So here is a link to the live share session on the web. So instead of launching Visual Studio Code, you can just join using your browser. I will do that here. So now I need to sign in. So I'm signing in with my Microsoft account this time. It should take me to a sign in. Things are going a bit slower here. Maybe I should try I'll try the GitHub account again. You can also join anonymously, actually. But then you certain features aren't disabled. I think you only join in read-only mode, or you have to request access. It seems there is a problem with signing in with code spaces right now. Anyway, that if it worked, it will basically open up in your browser a Visual Studio Code, and you can do most of the things that you can in your normal Visual Studio Code, except audio won't work. But you should be able to chat and modify the code and so on. Basically, that was a very quick introduction. Another thing actually I can show you is that you can share a terminal also, which is pretty good. So here you can also, but I think by default the terminal is read-only for other collaborators. So you need to make it, yeah. So not someone, yeah. So it should be possible for other people to yeah, run Docker PS or whatever there. No containers running. Yep. So that was a really quick demo of Visual Studio Code, and I think it could be useful. So I will use this tomorrow. Sebastian, what time do you think we should get started?
I can be at the same time as today, or maybe 1 hour later. It's at the same time of the 2-day start time would be okay for me.
It's fine for me to start later, actually. I'd rather sit in the evening.
Okay. At 7, so 1 hour 1 hour later than today.
All right, perfect. Well, yeah. So the other, I don't know, from Panasonic side, will you be also sharing your, because I know some of the people from my team would just like to see what you guys are doing, because your task seems very interesting.
Actually, my team from Vietnam is now coding. So, Kain-san, do you have any opinion? Kain-san. Sorry. Anyway, I'll ask the programmers about that. Sorry. No
Yeah.
response.
Okay. Yeah. Sure. No. If you, it would be great if you could share. Otherwise, I guess we'll see your presentation on Thursday.
Yeah. I'll share. We'll share 2 presentations.
All right. So basically, that's all I had for today. It's been a long day, but it's been very interesting for me. I hope it's been fruitful for you as well. Any last comments? Anything? Any feedback? All right, then thank you very much for joining. And here, if for the hacking task tomorrow, it's up to you to do whatever you want, and then you can prepare a presentation for Thursday. So I'll hear from you again on Thursday. Bye.
Okay, bye.
Bye.
Thank you. Goodbye.
Bye.
Thank you.